So hello and welcome back. Lecture 2-3 is all about circuit simplification, combining resistors in series and parallel in order to make the circuit easier to analyze to find voltage, current, power, resistance, etc. Please watch, enjoy, and most importantly, learn a lot. So today should be review for you because it is my expectation that everyone learned how to combine resistors in series and parallel in their physics course. Is that a good assumption? The biggest challenge we have is you guys don't know what series and parallel are. You can absolutely use a formula to combine things in series and parallel. The problem is you don't know what series and parallel are. And what I mean by that is that I still have students telling me when they see something like this, that R1 and R2 are in parallel, and they are not. Let me zoom in so you can see what I mean. If you do not have two elements that share a node pair, they are not in parallel. So R1 and R2 are not in parallel. Parallel means shares the same node pair. So let me give you two examples where R1 and R2 are in parallel. Here is an example where R1 and R2 are in parallel. Here's an example where R1 and R2 are in parallel. If there's any element in between them, they're not in parallel. Does everyone understand that? This resistor, R3, keeps R1 and R2 from being in parallel. Questions? Similarly for series, when two elements meet at a node, they are in series. So if I give you something like this, R2 and R3 are not in series. R2 and R3 are not in series. You cannot look at how things are laid out on the paper. You have to look at connection points. And that R2 and R3 are actually in parallel. If it helps you, circle the nodes. If it helps you, circle the nodes. But you cannot apply the formulas for series and parallel if you don't understand where series and parallel are. Elements that in series have the same current and can be combined. When you combine them, you add them together. Just take the sum of all the resistors. Elements that are in parallel have the same voltage. To combine them, it is 1 over the sum of the conductances, or 1 over the sum of the reciprocals of the resistances. Remember, conductance is just 1 over G. I'm sorry, resistance is 1 over G, so G is 1 over R. So the equivalent resistance can also be written as G1 plus G2 plus ... plus Gn inverse. So it's 1 over the sum of the conductances. Okay. Are there any questions? There's a special case for two parallel resistors that I use frequently in class because it's fast, where if I ask you to find the equivalent resistance between terminals A and B, the quickest way to do it is the product over the sum. This only works for two resistors. So the product over the sum would be 20 times 5 over 20 plus 5. is 4 ohms. Okay, I want you guys to tell me what is the equivalent resistance for 18 ohms and 9 ohms. 18 ohms and 9 ohms. 6. 18 times 9 over 18 plus 9 is 6. Are there any questions so far? Any questions? So remember, the other formula we had is that power is equal to voltage times current, and power is equal to I squared R, and power is equal to V squared over R. These are our power formulas that relate voltage and current and resistance. So now that I have reminded you of those, I want you to answer those 2 concept questions. The one at the top says, in the following circuit, a 75-watt bulb is in parallel with a 50-watt bulb, which is in parallel with a voltage source. Parallel, parallel, parallel means same voltage. Which of the following statements is true? The current through the 50-watt bulb is larger. The current through the 75-watt bulb is larger. They have the same current. None of the above, not enough information to solve. What is the answer? Talk it to your neighbors. Yes. Sure. Okay, so I equals P over V, right? So that means the current here is 75 over the voltage. The current here is 50 over the voltage. They have the same voltage, so which one's bigger? The 75, very good, okay? The current and the voltage are inversely proportional, directly proportional. I think it's inversely. Somebody tells me, one of my math experts, it's inversely proportional, right? So they have the same voltage, so the one with the higher power would get more current. Okay. Questions? All right, middle of the page. Try that concept question in the middle of the page. Sorry, I'm distracted. Back, focus, children. What's the answer to that middle problem? Stop shaking your head at me, Craig Jr. Craig Jr. All right, that middle circuit, what's the answer? B is in bananas, right? So the more resistors you put in parallel, the resistance goes down. We also have a special formula for this one. And the special formula for this one is, if you have a bunch of resistors and they're all the same, and let's say you have N of them, the equivalent resistance is the resistance divided by N. So here's an example. If I give you a 6 ohm resistor in parallel with a 6 ohm resistor, the equivalent resistance is 6 over 2, which is 3 ohms. So if I give you 2 6 ohm resistors in parallel, the equivalent resistance is 6 divided by 2. If I give you 3 6 ohm resistors in parallel, the equivalent resistance is 6 divided by 3, which is 2 ohms, and so on. What if you don't like these tricks? What if you don't like these tricks? What will always work? 1 over the sum of the conductances, right? You got to get the same answer or the tricks are no good. So if you're like, I'm never going to remember this stuff, just do 1 over the sum of the conductances, you still get the right answer. Questions? All right. So when you want to combine resistors in order to get the equivalent resistance and it gets more complicated, You always work from the outside in. You always work for the outside in. So if I'm trying to find the equivalent resistance between terminals A and B, I start on the far right and work my way to the left. Or I start at the furthest point from the terminals and work my way in. So if I'm all the way over here, the first thing I should notice is that I have a 20 in parallel with 5. What's 20 in parallel with 5? That's 4. Okay. So now over here, I have a 4 in series with a 1. What is 4 in series with 1? Does everybody see how I got 4 in series with 1? Then I'm going to do 4 plus 1, which is 5. What am I going to do next? Yes, Sam. I'm going to look at the 5 in parallel with the 20. And I want you to notice something here. It does not matter that the 20 is leaning to the side because my nodes are still connected at the top and the back. Doesn't matter whether that 20 is vertical, horizontal, leaning to the left, leaning to the right, push, pull, drag it, dented. As long as they're connected across a single node pair, they're in parallel. So 20 in parallel with 5 is 4 ohms. All right. So I'm going to draw a full circuit this time so we can see everything that we have left. We have an 8 here. We have an 18 here. We have a 9 here. A 2 ohms here. And then all that other stuff we put together so far, and it made a 4. So this is all we have left now. We know it's not in parallel with the 9, but what else could you tell me about it? What's the closest to it? The 2 ohm is the closest to the 4 ohm. So I've already told you they're not in parallel. So what could you tell me about the 4 and 2? Yes, yes. So when exactly 2 elements meet at a node, they're in series. That's all you can tell me. 4 and 2 are in series. Did that make sense? 4 and 2 are in series. 4 plus 2 is 6. Okay, so we're going to rewrite this as 6. Now, Nikki, once I put that 6 there, what can you tell me about the 6 and the 9? Nikki said, I ain't telling you nothing else because you just hazed the crap out of me. What can you tell me about the 6 and the 9? They are, Alex? If I put 4 and 2 in series, it makes 6, correct? Do you agree with that? And then they're connected here and here. Is that my definition of parallel?
But why is 6 on like the right side instead of?
Okay, okay, all right. I'm gonna roll with you. I gotta get you guys to understand this. So that's why I'm taking my time here. Like I told you about the positives and negatives yesterday. Until you get this stuff, there ain't nothing else we can do in here. Until you do right by me, that's from the color purple. Everything else you're gonna do is gonna fail. Alex, here's the question, answer to your question. I put the 6 where you wanted me to put the 6. You agree? You don't even know what the color purple is. Still 2 nodes. That's not what series means. Series means when 2 elements meet at a node. Do I have 2 or 3? I have 1, 2, 3 elements meeting right there. Series is 2 meet at a node. 3 is actually a T, which we haven't even talked about. But I want you to understand, Alex, there is no difference between this and this. These are identical. Whether I put the 6 here or the 6 here, all 3 of them are still in parallel. Blake.
Is there a reason you're not drawing the 8 ohm resistor diagram?
It's not relevant. It's coming up next. I need to make sure you guys understand this before I write the 8's coming next. The 8's coming down the pike. He's on I-70, but he ain't made it to 46 yet. Okay, 18 in parallel with 9 and parallel with 6. What is it? 18 in parallel with 9 and parallel with 6. What is it? $18 in parallel with 9 and parallel with 6. What is it? 3. Okay, and then Blake, you're up with the 8. So now Blake, your 8 is back. What is RAB? What is the resistance across A and B? A and B are in series. Alex, there are exactly 2 elements here. They meet at a node that's series. 8 plus 3. The equivalent resistance is 11 ohms. It is hot as fish grease up in here. I am hot. All right, so it says, what if I put a 10-volt source across this network? What if I put a 10-volt source across this network? The easiest way to solve this is to simplify it down to one resistor. That's 11 ohms. And if the question says, what is the power developed in the circuit? Or what is the power delivered by the source? What is the power? The formula is at the top of the page. What is the power developed in the circuit? What is the power delivered by the source? What is the power developed in the circuit? What is the power delivered by the source? 91? 9.1. I'm going to trust you on that. 100 divided by 11 is 9.1 watts. So I have a network of resistors here, and I want to find the equivalent resistance. I always work outside in. I always work outside in. So starting on the outside, I have a 1K and a 1K. What can I say about those two 1Ks? They make a 2K because they're in series. 1K plus 1K makes 2K. So now, on the far right, I have a 2 kilo ohm and another 2 kilo ohm. What can I say about the 2 kilo ohms? 2 kilo ohms, sorry. Alex?
Oh, they go to 1 kilo.
They go to 1 kilo ohm because they are in parallel. 2K in parallel with 2K is 1K. I'll draw the whole circuit so we can keep up with where we are in the process. Okay, this is where we are now. What can I say about those two 1 kilo ohm resistors? What can I say about them? Is your hand up?
Yes, my hand is up.
What can I say about the two 1K resistors? They're in series. So it's 1K plus 1K is 2K. Okay, we're almost done. We're almost done. Okay. All right. What can I say about the two 2 kilo ohm resistors? I'm not going to let you answer. I know you know the answer, but I'm not going to let you answer. I'm going to let John answer. John by the window. 2K in parallel with 2K makes a 1K. Very good. Okay, and then I'm going to let Taylor, John's bud, answer the final question. What is the equivalent resistance that we see between terminals A and B? A 2 kilo ohm resistor. 1 kilo ohm plus 1 kilo ohm equals 2 kilo ohms. Okay. Are there any questions about how we did that? Always start from the outside and work your way in. Outside in. Yes. See what happened? I get so distracted. Blake been trying to tell me that was a 10 for 30 minutes. Is it a 10? Okay. It's 10 milliamps. Sorry, 10 milliamps. Are you good, Nikki?
Yeah.
So get your calculator out, just have it out during class, and whenever I'm doing that stuff, you just do 1 over, 1 over, plus 1 over, plus 1 over. That's always going to work. What is the power delivered by that 10 milliamp current source? What is the power delivered by the 10 milliamp current source? 10 milliamps squared times 2K is 200 milliwatts? Very good. Okay, any questions? Yes. These would be modeled as, so here we're just talking DC circuits, but in reality, these could be modeled as different loads. So let's say you were trying, I'm making this up and it's going to sound ridiculous, but you're trying to power like a system with a refrigerator, your lights, and a stove or something. So although we're showing these all as resistors, there could be in theory be different loads of things that you somehow need to combine to find the power delivered. Like how much power do I need to turn all this stuff on? We just show them as resistors. And the other benefit for us is what we're doing in here, eventually sometimes simplifying the circuit like this, it's easier to get the answer than looking at the more complicated one. So voltage and current divider, which I'm about to show you, is an example of that, where it's a whole lot easier to simplify it and find voltage and current than to keep the original circuit. So this is a simplification technique to make it easier. Kind of like my whole product over the sum thing I just told you. These are simplification strategies to make it easier, but if you don't like none of that, you can always just do the original complicated circuit and solve it. And it'll still work as long as you don't make a mistake. If a 10 milliamp, okay, what is the current through each of the 2 kilo ohm resistors? So the question is asking me, what's the current here and what's the current here? The easiest way to do this is to walk through the circuit, and I'm getting you ready for current divider, okay? So if I want the current here and here, I'm going to start down here and work my way back up to here to answer the question. Yes. Okay, so if I step back up to here, both of these resistors would still be 10 milliamps. Does everyone see that? If I step back to here, this resistor would be 10 milliamps. But then when I get here, the current divides. The current divides because it has to split at that node. What does it divide into? Why is it 5 milliamps? You're correct, but why is it 5 milliamps and 5 milliamps, Sam?
Because the resistors are equal, so it'll split evenly.
Because the two resistors are equal, it splits evenly. So 10 in, 5 and 5 out. Does everyone see that? Okay, let me know when I can move on. Okay, so now we're back here. This is 10 milliamps. This is 10 milliamps. And now I have my first answer. Because of that split, the current down through that 5 milliamps is, I'm sorry, I just gave you the answer, sorry. The current down through that first 2 kilo ohm is 5 milliamps. I don't know where the rest of them. Yeah, let's just go with this. Okay, so this is 5 milliamps. And this is 5 milliamps. You see that? It did not matter whether the 2K were together or I split them back apart. It's still 5 milliamps here and 5 milliamps there. That has to add back up to the 10. Does everyone see that? I don't like this one. Let me find a different one. Okay. So now I am back to the original circuit. I think we're ready for the original circuit. So I'm going to start labeling currents on that original circuit. If I can find a colored pencil that I like. Let's try this one. No, I don't like that one either. So this is 10 milliamps. This is 5 milliamps. And this is 5 milliamps. 10 comes in, 5 goes here, and 5 goes there. Then when I get over here, the 5 has to split again. If this is 2 kilo ohms and those two together are 2 kilo ohms, what is the current here and here? Prana, 2.5. Okay, so this is an example of the current divider where I didn't have to worry about any other math because it was always evenly divided. So 10 gets split evenly, 5 and 5. 5 gets split evenly, 2.5 and 2.5. Are there any questions? Okay. Let's try to get through one more problem before the bell rings. One more problem. Okay. I want to find the equivalent resistance for that circuit. I want you to work with your table mates and solve it. It always looks easy when I'm doing it, but how does it look when you're doing it without me? All right, I'll give you your first hint, but you keep working. The 1 ohm is in parallel with 12, in parallel with 4, it's in series with 12, in parallel with 4, in parallel with 6. That's your first hint. Keep going. Here's your second hint. How many people made it that far? That's no bueno. It's like 4 people. Okay, got to go back and fix that first, right? 12 in parallel with 4 in parallel with 6 is 2. 3 in parallel with 6 is 2. This is the same 1 ohm resistor that's been there since the beginning. This is the same 10 ohm resistor that's been there since the beginning. All right, have a good weekend. We will start here on Monday. Have a good weekend. We will start here on Monday. The answer is 11.2 ohms. If you got 11.2, you're doing pretty good.